Good afternoon, everyone. I'm Jeff Kinnison from the Computer Vision Research Lab at the University of Notre Dame, and I'll be talking with you about massively scalable hardware-aware distributed hyperparameter optimization with our framework, SHADHO. As a quick review, hyperparameter optimization is the process of selecting hyperparameters for a given learning model that optimize the model's ability to learn patterns from the data set you're interested in. These problems are typically set up by selecting a few discrete models that you would like to test, and then defining domains for each hyperparameter within the model. So in this example here, we have a toy problem where you're checking a one-layer versus two-layer versus three-layer convolutional neural network, and you can see that there are two hyperparameters defined here that are global to all the models, and then each model has its own set of hyperparameters associated with the layers. This is a highly structured problem that each model can be evaluated and tested independently. So turning to distributed computing, we see that we can set this up in such a way that we define our models. We then select a large number of parameterizations of each model, and finally distribute them out to available hardware on, say, a compute cluster or AWS, something along those lines. And after testing a large number of these, we get the optimal discovered model. So knowing that this is a highly structured problem, knowing that, that we can evaluate these models independently, we have to ask the question, can we use details about structure and performance to increase the throughput of hyperparameter optimization, because we want to check as many models as possible in the shortest amount of time. So what we did was we defined two heuristics for ranking models in a hyperparameter search. The first is we call complexity, and it's an approximation of the combinatorial size of the hyperparameter search domains in a single model. This is divided into discrete and continuous hyperparameter spaces, and what it does is it gives us a sense of the size of a search for a given model. The second heuristic is we call priority, and it's an approximation of the confidence we have in a model's performance over different hyperparameterizations. And what this tells us is it gives us a sense of the fitness of the model for a problem and how much more of the hyperparameter space we should explore for that model. Returning to the distributed hyperparameter optimization, typically we just distribute these models to the first available hardware. But our framework SHADHO implements those two heuristics, and the way that the search proceeds is it initially ranks each model in the search by its complexity. So the highest complexity models are sent to the highest performing hardware, lowest complexity models are sent to the lowest performing hardware, under the assumption that a greater complexity means greater running time. As the search proceeds, we add in priority to the ranking, and we start searching models that are both more complex and that we're less certain about their performance. And so in this ranking paradigm, we're statically and dynamically determining the ranking and updating this so that the models we need get the most coverage when it's needed. To evaluate this against existing methods, we did a simple optimization of SVM for MNIST over 4 standard SVM kernels: linear, RBF, sigmoid, and polynomial. And each of these kernels has a different number of hyperparameters, so different complexity. They're also going to have different performance on the data given their different parameterizations. And what we found was that over 48 trials, SHADHO was able to increase the search throughput by a factor of 1.8 over HyperOpt and over itself. So by distributing based on these heuristics to the correct hardware, we can search through double the number of models that a first come first served method could do. We then applied this to optimizing UNet for EM membrane segmentation, and we discovered a large number of models that outperformed standard UNet on this problem. So the takeaway is that heuristic-based hardware assignment significantly increases hyperparameter optimization throughput through a simple method, and SHADHO is viable for exploring new problem domains. So thank you very much for your time, and come see me at the poster session later.